Welcome to this presentation on understanding disproportionality methods, specifically how we identify risk and determine risk ratios. Note the word that's emphasized in both italics and in underline is understanding. It's imperative that we know why we engage in the calculations and algorithms that we do to compute these metrics, because we are talking about the lives of our students. And these measures lend insight into whether or not the policies and practices in our LEA lead to equitable decisions across racial and ethnic groups. So as we get into this, those little squiggly lines that we refer to as numerals and math symbols have true meaning that impact the lives of the kids in our LEA. So because of that, we have to understand these metrics, we have to be able to communicate them well to our staff and stakeholders, and we have to use these data to impact positive changes when we find inequity. So to understand disproportionality, we really need to understand proportionality. So I want to start with a definition. For something to be proportional, it means that there's a relationship, and that we can understand that relationship through the operation of multiplication. Let me give you an example. Let's say that we're going to draw some shapes. I'm going to draw a triangle, a circle, and a square. I know that there are some relationships that exist between these shapes. So I want to know, what is the relationship between triangles and the total number of shapes? I can write that as one triangle for every 3 shapes. I can present that in a form that's known as a ratio. One triangle for every 3 shapes. Now I can understand this relationship through the operation of multiplication. I know that if I multiply the one triangle by 3, I'll get the total number of shapes. So proportionally, this relationship, we can understand it through multiplication. Multiplication by 3 gets me from the triangle to the total number of shapes. Now, say I repeat this pattern, and I now have 2 triangles to 6 total shapes. 2 triangles to 6 total shapes. That relationship has remained constant. I can say that 1 triangle to 3 total shapes is equal to 2 triangles to 6 total shapes, because the relationship between 1 and 3 is equivalent to the relationship between 2 and 6. Notice when I'm saying equal, I'm not saying that 3 is equal to 6. I'm saying that the relationship between 1 and 3 is equal to the relationship of 2 and 6. So I did that demonstration about what it means to be proportional because we have the great privilege to work in racially and ethnically diverse LEAs. And when we begin to think about how our policies and practices, whether they result in equitable decision making, thinking proportionally in this way becomes advantageous because we don't have an equal number of students within each racial or ethnic group. So, for example, 10 out of 100 students means something very different than 10 out of 1,000 students. So our ability to think proportionally has some nice relative advantages when we begin thinking about whether the decisions we are making result in equity. So, how can we use what we know about proportionality to analyze the decisions we're making for equity? Well, let's say that we're interested in the educational placement of students within our LEA. Particularly, we're looking at students who have a fairly restrictive setting, that they're receiving less than or equal to 39% of their instruction within the general education setting. We want to know, are we applying this in educational placement equitably across all races of students in our LEA? So the first thing that we have to do is determine the risk, or to determine the proportion in which this decision is being applied for a particular racial group. Let's say that we're focused on African American students. And we know we have 300 total students. These are hypothetical data. The data are not intended to approximate any types of data across the state or in any particular LEA. I'm using them for ease of understanding. So let's say that we have 300 total students with disabilities in this fictional LEA that happen to be African American. Out of those 300 total students, 100 of them, let's say, have an educational placement that is less than or equal to 39% within the general ed setting. So what we know from this is that this is a ratio and that there's a relationship that has to do with multiplication. I can understand it through multiplication. If I take this and multiply it by 3, the number of students that have this setting, I will have the total number of students with disabilities who are African American. So what does this look like? I can also find what's referred to as a unit rate. What this means is for African Americans in this LEA, 1 out of every 3 students is in this setting. Okay, so proportionally, I can understand how this setting is being applied to African American students. Now, to understand if there's disproportionality, I have to compare these data to all the other students in the district. All right, so what we've established is for African American students with disabilities within this district, 1 for every 3 students is within this educational placement. We want to know, is this disproportionate? Are we applying this setting disproportionately to African Americans compared to all other students with disabilities within our LEA? So let's say we pull the data for all other students, all other racial groups other than African Americans, and let's say we have 600 total students with disabilities, total other students with disabilities. Out of those 600, let's say 200 of those students have the educational placement of less than or equal to 39% in the general education setting. Are we proportionate? How do we know? How do we figure that out? Remember, proportionality is about a relationship that we can understand through multiplication. We understand this relationship through multiplication. 1 student in this placement out of 3 students in this particular ratio. We understand that as multiplication by 3. What's the relationship between 200 and 600? It's also, we can understand that relationship as multiplication by 3. So what we know for all other students is we have the same proportional relationship, that 1 out of every 3 students that are not African American students with disabilities also have this same educational placement. So the risk ratio, it's the ratio between this, the 3 and the 3. What we know is that is 1, right? These are equivalent. So we are proportionate. We have a risk ratio of 1 in this situation because we are applying this setting equitably between African American students with disabilities and all other students with disabilities within the LEA. All right, this time, let's say we have a different scenario. Say we still, when we're comparing African American students with disabilities to all other students with disabilities in the LEA, again, let's say we have 600 students with disabilities that are all other races besides African American. However, instead of 200 students that have this instructional setting, let's say only 100 students have that instructional setting. Is that proportional? And if not, what's the risk ratio associated with that? Well, let's think through this. We know that the relationship for African American students with disabilities is 1 out of every 3. How can we understand this relationship through multiplication? This would be multiplication by 6, right? So what we know is that 1 out of every 6 students in this scenario has, out of all other races other than African Americans, have this instructional placement. So when we look at the relationship here, 1 out of every 3, that's a relationship of 3. This is a multiplicative relationship of 6. Remember, when we're thinking about risk ratio, it's how we understand the difference between these two numbers here. What is this? Let's see. A student, an African American student, 1 out of every 3. All other students, 1 out of every 6. These students are twice as likely to be in this instructional setting relative to all other students. 1 out of every 3 compared to 1 out of every 6. The multiplicative relationship between 3 and 6 is 2. African American students are twice as likely to be in this setting. We're disproportionate. Here we have a risk ratio of 2. So the important thing to remember when we're talking about risk ratios is that we're dealing with multiplication. And even though a risk ratio of 2 or 3, 2 and 3 seem like they might be small numbers, but when we're talking about doubling or tripling, it's really a massive, massive difference proportionally. So if we think about a risk ratio of 1 out of every 3 students compared to 1 out of every 3 students, we have proportionality here. About 33% of the students in this situation, about 33% of the students in this situation, a risk ratio of 1. However, once we get up to a risk ratio of 2, that's 1 out of every 3 students compared to 1 out of every 6 students. Just visually look at this. See how much more likely this group of kids is to meet this specific criteria. And then when you get to a risk ratio of 3, you can see visually just how starkly different this is. How the likelihood of a student in this to meet the criteria is just so much greater than this. So when we're thinking about risk ratios, remember it's multiplication, twice as likely, 3 times as likely. That's really big.